Alright, we are starting the tangent translating and reciprocal unit. This is lesson 1 where we talk about the tangent function. Today's date is today, and our objective is to graph the tangent function. So, you're probably asking yourself right about now, what is the tangent function? Well, we already know a few pieces of information. We know x is cosine theta, or cosine theta is x. We know sine theta is our y. Tangent is actually sine over cosine, or y over x. That piece of information that I just circled there is going to be very important. You need to know that for the lesson quizzes and for your tests. Tangent theta is y over x. So on your unit circle over here to the right, our radius would be 1. That ratio of y over x for our coordinates around the unit circle is what's going to give us tangent. So let's go ahead and do a couple of them. So on this first one, we have our unit circle here. Imagine that as a better drawn circle. And what we've done is we've gone around 2 pi, and we've ended up right there. And our ordered pair is 1, 0. So the tangent of 2 pi is going to be your y-coordinate, which is 0, over your x-coordinate, which is 1, which will give you 0. So the tangent of 2 theta is 0. Let's do another one. This one's kind of hard to read, that ordered pair, and that angle there did not get drawn. It would be right there. And that ordered pair is radical 3 over 2, 1/2. So if I want to do my y over x, that's going to be 1/2, my y-coordinate, over my x-coordinate. And we end up with a complex fraction. We don't want that. Remember, a fraction really just means dividing, so we're taking one fraction, dividing it by the other. When you are dividing fractions, that is the same as multiplying by the reciprocal. The 2's cancel, and I end up with 1 over radical 3. But we can't have a radical in the denominator, so we're going to have to rationalize. And you're going to end up with radical 3 over 3. So the tangent of pi over 6 is radical 3 over 3. Let's do another one. Let's figure out the tangent of pi over 3. Again, that ordered pair there is 1/2 radical 3 over 2. So my y-coordinate is radical 3 over 2. My x-coordinate is 1/2. That is the same as saying radical 3 over 2 times 2 over 1. And I'm just going to be left with radical 3. So the tangent of pi over 3 is radical 3. All right, the tangent of pi over 4. Well, this one I think we can actually do in our head, because you're going to get radical 2 over 2 all over radical 2 over 2. Anything divided by itself is 1. So tangent of pi over 4 is 1. All right, this one's not drawn out quite as well, but let's go ahead and figure out what the tangent of pi over 2 is. That would give me my y-coordinate over my x-coordinate. Well, from Algebra 1, or actually before that, we know we can't divide by 0. If you ever get anything divided by 0 that's undefined, When we start graphing that, we're going to show that undefined area with an asymptote. So let's talk about what the graph of a tangent is going to look like. You're going to have two, or actually more than two if you draw more than one cycle, vertical asymptotes. That's where your graph is undefined. This doesn't look anything like the sine or the cosine graphs that we had been graphing. These ones are totally different. Here on the origin, we have what I call the turning point, where you kind of have a change in concavity, and then it's going to approach that asymptote and get really close to it towards positive infinity in the y direction, and it's going to get really close to it, negative infinity in the y direction on the left-hand side. And this is one period that they're showing here. We could be graphing more of that if we wanted to. You could have another one. Oh, that's not drawn well. But you'd have another one off to the side here. You could have one right here as well. And that could go on forever and ever. So let's go ahead and figure out how do we find our period and our asymptotes. Well, the period is going to be pi over b. Your asymptotes, well, are going to actually be, and I'm going to use VA to show vertical asymptotes, it's going to be plus or minus pi over 2b. Because one cycle occurs in that interval, and you're going to have asymptotes at the end of your cycle, end and beginning of your cycle. So let's go ahead and figure out some periods and some vertical asymptotes. Well, in this case, our b is 3, so our period is going to just be pi over 3. Our vertical asymptotes are going to be pi, and 2 times 3 is 6. And I always want to put a plus or minus because it's going to happen at positive pi over 6 and at negative pi over 6. For this one, our period is pi over 5. And our vertical asymptote is happening at plus or minus pi. And it's going to go over 2b, so that'd be 2 times 5, which is 10. Now this one's a little bit different because our b is actually 3 pi. Don't think of pi as a variable. Think of pi as a constant. It's a number. So my period is going to be pi over 3 pi, which is 1/3. My vertical asymptote is going to be pi over 6 pi. Don't forget my plus or minus, which is going to be plus or minus 1 over 6. Period. 1 pi over 4. Vertical asymptote, pi over 8. Not the best drawn pi there, but you can get the idea. Let's do a couple more. Period is going to be pi over 6. Vertical asymptote, plus or minus pi over 12. If you're noticing a pattern, the vertical asymptote is really the period multiplied by 1/2. The period here is just going to be pi, because it'd be pi over 1, vertical asymptote, plus or minus pi over 2. All right, let's actually graph some of these now. So on the first one, we're going to just go with a really basic one. And we're going to graph a couple cycles. So I've got my period is pi. 2 of my asymptotes are going to happen at, actually instead of writing it as plus or minus, we'd have one at positive pi over 2. We'd have one at negative pi over 2. So let's go ahead and sketch those in first. Let's say that it right there is negative pi over 2. There's 0 right there. That would make that pi over 2. And when I am sketching my vertical asymptotes, I usually just use a dotted line to kind of show that it's going to be an asymptote. Oh, and I try and draw it straight too. Alright, not the straightest. That's going to give me one cycle. I want another cycle. So, right here is going to give me my next asymptote. Oh, that's a lot darker. Let's make those all match. Okay. So, to figure out what that is from here to here is one period. And we know a period is pi. So if I take my pi over 2 and add pi to it, I'm going to get 3 pi over 2. So that hash mark there is 3 pi over 2. The distance from here to here is also pi because that's going to give me one cycle. So when I'm graphing these, I usually go ahead and put a couple more hash marks in between. And that origin right there is what I refer to as my turning point. From there, go right one, up one, or actually go midway between your turning point and the asymptote, and then go up 1 unit. Go midway between your turning point and the asymptote and go down. And I am not the greatest at sketching these, but we'll give it a shot. Alright, I'm going to do the same thing. My turning point is halfway between my two asymptotes. Go another half and up one. Go back half and down one. Kind of missed that one right there. But I think you can get the idea. And if I wanted to, I could keep on sketching more and more periods. It would just be the same general shape over and over again. Let's do another one. All right, we got 3 pi theta. So let's go ahead and we're going to figure out our period, which would be pi over your b. So in this case, we're just going to get 1/3. My vertical asymptotes are going to be negative 1/6, positive 1/6, and to get that third one, it's just going to be 1/6 plus 1/3. My right vertical asymptote plus my period, get a common denominator. And I get 1/2. All right, let's go ahead and sketch those lines. Get a little bit smarter on this one. I'll use the smartboard to help me out. Try and space those a little bit better. All right, let's draw in some hash marks. Right there would be midway between my two vertical asymptotes. Let's label this. This would be -1/6, +1/6, and +1/2. Put in my turning point and a couple of guide points and do my best to sketch. But we can do better than that. Let's try that again. Put my turning point in between my two vertical asymptotes, a couple of guide points, and let's sketch that again. And there we go, 2 cycles. Let's do one more. My period is going to be pi/4. I'm going to have vertical asymptotes at -pi/8, +pi/8. Go ahead and put those in right now. -pi/8, there's 0, pi/8. And to find that last one, take my asymptote, add my period to it. If you got a common denominator, you're going to get 3pi/8. Draw some hash marks. All right. Put my guide point right there in the center between my two asymptotes. Or my turning point, a couple guide points. Turning point, guide points, and sketch it again. All right, that's all we have for today. Hope you enjoyed.